Another flux problem. Um, so the problem is there's a cylindrical surface like this, and the electric fields are on the left cap of the cylinder. The electric field at this left cap surface is uniform, either at 6,000 Newton per coulomb all throughout the surface. But this doesn't mean that the electric field is the same everywhere. When you come to the right cap, uh, on the right cap at every point, the electric field is given as 1000 Newton per coulomb. So it seems that the electric field is entering from the left cap and leaving from the right cap at different values, but they're direction-wise, both electric fields are just perpendicular to the cap surfaces and to the right. So we have a coordinate axis over here. It's always in the x direction. The direction is the same, but it has the values, different values on the left cap and the right cap. The cylinder is given as the diameter to be 0.2 meters, so the radius is 0.1 meters, and the length of the cylinder is given as 0.8 meters. These are the parameters for the problem. So the question is, what is the flux? What is the flux uh, entering the cylindrical surface at the left end? Okay. So what is the flux entering the surface? Well, let's put this is at E1 6000, right? 6000 Newton per coulomb, and E2 is at 1000 Newton per coulomb. But this one is not gonna change anything for the question and the problem, because the question only asks the what is the entrance flux to this cylindrical volume. So it appears that we're going to use only this value to calculate the influx, the flux into the volume. So let me switch to larger. So this is E1, this is E2. Okay. So uh, since again the electric fields are uniform at given surfaces, you know, although it doesn't change. Well, we only care about the electric field entering the left cap, okay? And the electric field is uniform throughout the left cap. It has this magnitude of 6,000 nanocoulomb fixed, constant, and the direction is always again to the x, positive x direction always. We can use this simple flux expression E dot A, okay? But what about the area vector on the left cap? So since the area vectors are always pointing outwards to the outward of the volumes, uh, at the left cap, the area vector is going to be to the left, okay? We must have to the left. Sideways, they are going to be radially outward concerning the axis or the x-axis. They are going to be outward, all the area elements, area vectors. And on the right cap, the area vector is going to be toward right in the positive x direction. Okay, let's call this one A2 and this one A1. Because, the area vector for closed surfaces must always be pointing out of the volume. So that is the convention. That is, this is the only way that we assign the directions to the area vectors. So we are asked about this E1 dot A1. Okay. So E1 is as a vector 6000 I, because it's pointing toward the positive x-axis, But A1 is pointing toward the negative x-axis. It is going to be, the area of the cap, which is pi r square multiplied by minus I. Okay? Minus I because it's pointing toward the left and it's pointing the direction of the negative x-axis. So obviously, when you calculate this dot product, it's going to be negative. It's a negative flux. So R is 0.1 and R square is going to be 0.01. So let's do this. I dot I is 1, but we have a minus sign. So 0.01 multiplied by 6,000 will make 60 pi Newton meter square divided by Coulomb. So that's it. This is the flux that enters into the volume. Okay. So this is one part, and the other part is what about the flux at the right cap? We can calculate also this one. So let's name this one as phi 2, E2 multiplied by the dot product with A2. Well, A1 and A2 in terms of area wise, they're equal to each other, but only the difference is that they are just, directions are opposite. So E2 at this cap is just, 1000 1000 I, and A2 is again pi r square pi r square I, positive I. So this will produce a positive flux of plus 10 pi Newton meter square divided by Coulomb. So this is the flux which is out of the volume of the cylindrical volume. And next question might be, what is the net flux? Net flux through this volume of cylinder. Okay, net flux. Well, sideways, the flux through the side surfaces is going to be zero because the electric field defined to be at the left and right caps only. Well, if there is an electric field, the electric field is continuous, so the direction is toward right. So since the area vectors of the side surface at every point is going to be perpendicular to the electric field, so it will produce a non-zero flux through the sideways. So the net flux is going to be phi 1 plus phi 2, phi 1 plus phi 2, and it is minus 60 pi plus 10 pi is going to be minus 50 pi. Okay, so this is the net flux. So if there is a net flux of negative quantity for a closed volume, this shows that there are some negative charges inside, some net negative charge inside this volume. By using Gauss's law, we can calculate the negative net charge inside this cylindrical volume, because this flux is going to be the charge inside the cylinder divided by epsilon 0. It's very straightforward to calculate the Q inside the charge inside the cylindrical surface. It's going to be minus 50 pi multiplied by epsilon 0 Coulomb. Okay, epsilon 0 is, if you take 8.85 times 10 to minus 12. So this is going to be the net charge inside the cylinder by just calculating the flux through the surfaces of this cylindrical volume.